Hello and welcome to episode 210 of our SAP on Azure video podcast. Today is September 26th, and together with Robert and Goran, we're here to talk about anything related to SAP and Microsoft. Hello, everyone. So recently we talked about the release of virtual machines with 32 terabyte of memory on Azure. This allows you to run the most high-demanding SAP workload on Azure. With some innovations, it takes some time to adopt, but apparently with the 32 terabyte system, that was not the case. I'm really happy to have a team with us today that worked on customer projects already using these 32 terabyte machines. So Abbas, Ralf, Momin, and Chris, welcome to our show.
Thank you.
Abbas, maybe let's start with you. Let's get started with you. Can you kick us off and talk a little about the 32 terabyte project and maybe then also introduce everyone?
Sure. Let me share my screen.
Yeah, perfect. It's coming up. Fantastic. Now, Jan, you need to switch. Now we again see the presentation view. Let's change.
Hello, everyone.
Perfect.
Today we'll be focusing on running SAP on Azure on the very high memory 32 terabyte VMs. We'll be reviewing a case study of one of the largest SAP on Azure customers, Fortune 50 retail consumer goods company that very recently went live with the S4 HANA on 32 terabyte VMs. This is the system that they're running today kind of handles more than $40 billion of transactions on an annual basis. We have a strong mix of presenters today, both from field and engineering, that have been very closely engaged with this customer, and we'll walk through our experience and the journey we had with this customer. With that, I would like to say I'll start with myself, and I'll hand it over to the other presenters. I'm Abbas Alimir. I'm a principal CSA, and have been working at Microsoft for the past 10 years, covering some of the largest SAP on Azure customers. With that, I'd like to invite my engineering colleagues to introduce themselves. Ralf?
Yeah, my name is Ralf Klahr. I've already done a couple of presentations here with the team on the channel. Yeah, I'm basically the storage subject matter expert for that project, taking care of the storage design and also pretty much engaged in the performance tests and doing this test.
And Ralf, since you mentioned this is not your first time here, so
No.
we expect obviously a recipe from you again, hopefully.
Of course, a very good one. Actually, it's not my recipe. It's made from my manager, from Jürgen
Cool.
Thomas. He was also a couple of times here in the channel. He surprised me with this when I did one of the visits to Redmond, and I can tell you it's really amazing.
Perfect. I'm looking forward to this. Momin.
Yes, Momin Qureshi. I'm based out of Atlanta, Georgia. I'm from the Microsoft Customer Engineering team, and I really specialize in bringing SAP workloads onto Azure. And I will pass the baton over to Nolan here.
Hello, I'm Christopher Nolan. I'm a principal reliability engineer in our customer reliability engineering team here in Redmond, and I'm happy to join you for the first time.
Thank you so much. Great to have you.
Thank you. With that, I think we'll get started. As for the agenda, we were going to talk about the S4 HANA architectures, how it is laid out from a high availability, disaster recovery, and also how did we cut over from 24 terabyte VM architecture to a 32 terabyte VM architecture from a migration standpoint. Followed by Ralf, who will kind of go through the SAP HANA file system storage layout in depth. Momin will cover the SAP deployment best practices and go live readiness, and Nolan will walk us through the VM specs in detail, along with the SAP certifications for the VM and certain platform improvements that we brought in as part of this architecture. And finally, we'll have a nice recipe from Ralf. Before I kind of start out on this architecture, and I think it's important to understand that architecture is going to get built out. Let me kind of start. Oops, sorry. Let me start. Get my pointer going. Okay. So this is a high availability architecture of the S4 HANA, and we're going to talk about 24 terabyte VM architecture first, because that was prior to the cutover, and then we're going to kind of walk through with how we kind of migrated to the 32 terabyte VM architecture. So this was in primary regions, South Central US, with 3 zones, AZ1, AZ2, AZ3. We did set up a cross-zone high availability architecture, which had an availability uptime of 3 nines, which really translates to less than 7 hours of downtime a customer can afford for unplanned outages. It had an RPO of 20 minutes and an RTO of 30 minutes for the high availability design. I'm going to go bottoms up to kind of explain the architecture. From the bottom, you can see we have 2 VMs, which are the HANA database VMs. And we did achieve high availability by using the HANA system replication synchronous and pacemaker clusters, and the Azure load balancer zone redundant was used to kind of front-end the 2 HANA database VMs. Going further up, the app servers, we basically use an availability set architecture to deploy the primary and the additional application servers across 2 availability sets in each of the zones. We also made use of something called proximity placement group, which in a sense allows these app servers to be in close proximity to the database server by getting them deployed in a same data center in each of the 2 zones. For the SAP shared storage, which hosts your SAP mount, transports, and interfaces, we use the ANF architecture, and we use the ANF cross-zone replication to achieve high availability. The SAP Central Services VMs, again, with 2 zonal VMs that were deployed across 2 zones, and we achieved high availability using the pacemaker clustering. And we had the web dispatches, not only supporting this S4 system, but other SAP systems, and they were deployed across 2 zones, fronted by a zone redundant load balancer. To establish quorum with pacemaker clusters for HANA and for the central services, we did use the SBD VM architecture, and they were deployed across 3 zones. Now keep in mind this. Go ahead.
So sorry. So the customer was already running on 24 terabyte virtual machines, but then I guess the sizes were not large enough, so they needed to. Wow.
Correct.
Okay.
So we are at a point where this customer's journey, and it's a good question, started out a few years back when they initially had the S4 system on 6 terabyte VMs, and then they moved to 12 terabyte VMs, and then they moved to 24. Currently, they have like a 13 to 14 terabyte database, and if you add the working memory, they're kind of almost scratching the surface with 24 terabytes now. And that next step, which we have gone up to 30 terabyte VMs, may not last more than 6 months, honestly. I think the expectation is in 6 months or so, there is a scale out effort that would be also used to kind of scale them out to 2+2 architecture, 32 terabyte VMs in 1 zone, another 2. So that's what I think we are looking forward to going, in near future. So, but at least this gives us a 6 months runway for us to work with. The other thing I do want to highlight on high availability architectures is that from a customer standpoint, we use the pacemaker clusters with SBD VMs, and it works perfectly fine for this customer. The other customers with all the other slight variations that you can use, like instead of SBD VMs, you could also use Azure Fencing Agent, or you can also use the Azure Shared Disk architectures to establish quorum, and other customers have leveraged that. Similarly, on the app server side, we have used availability sets because customer was keen on making sure the app servers in the database stay in the same data center within a zone. And the only way for us to achieve that was using the proximity placement group and doing it. But there are other customers out there who are actually using VM scale set architectures to deploy the app servers in a VM scale set where the VMs will get distributed within data centers in a single zone. So you could use that architecture, but then the app servers would be spread across multiple data centers, which this customer was not inclined to have. So we had to kind of go with this architecture. Again, on the SAP shared storage, we use the ANF architecture, and that kind of brought down our RPO from, otherwise the database RPO was 0, but because of this, the overall system RPO dropped to 20 minutes, just because the ANF cross-zone replication supports 20 minutes RPO. But there is some future work that's going on with ANF Snap Mirror Sync solution coming in future that would eventually make this RPO 0. So there's some positive development on that front. Now, there are other options customers have also leveraged, other customers like Azure Premium File Shares, which does provide you with an RPO of 0, and there is another solution like NFS clusters with CBO and whatnot, where customers have used to further improve this. But ANF has been a very solid, proven platform, so that's the reason customers are very inclined towards using this and continue on with it. Other than that, I think this kind of sums up the high availability architecture for us, and then I'm going to extend this out to the DR architecture. So from a DR standpoint, all we have done is that we have taken this database and we have kind of extended out to have another database VM over here. And as you can see, it's a dual purpose QA plus DR, which in a sense means it's not only hosting a QA database, but also the DR database. And we have set up HANA system replication asynchronous to over here to facilitate the DR for database. For the app servers, the central services, ASCS, ERS, and the web dispatches, we have used the Azure Site Recovery solution to basically protect these VMs and replicate and ensure in the event of a failover, they will come up on the other side. It
is amazing to see how these days the DR becoming a commodity. I mean, that was a science fiction before the Azure, really, which is great to see.
But it would be always a native offerings that kind of facilitate.
One question regarding DR. What was the target RPO, RTO for DR?
So the RPO for DR is 30 minutes, and the target RTO for DR is 4 hours.
Right.
So yeah, because the understanding the customer went was that the likely scenario that most likely they will probably end up losing a zone. In a worst case scenario, and they will be able to fail over to another zone. So they'll most likely stay in the region for the most part. In a very highly unlikely scenario, they will probably have to fail over a region to go to the other region. And that's the reason there was a lot of emphasis on setting up a robust high availability architecture and, a bit relaxed DR, if you will.
But they are at the same time saving money because there's a QA which is running on the DR side, so this is actually saving money, and actually they are somehow prepared to reuse existing virtual machine. They are not going into risk to not having those virtual machines if they are switched to. Okay,
absolutely.
Good.
Yes. Good. The other thing which we are also trying to bridge the gap. Currently, ANF supports does not support multi-target, which in a sense means that you can do either ANF cross-zone replication or you can do ANF cross-region replication, but not both. But that capability also is being unlocked, and hopefully starting of next year, you will probably start to see that capability become more available, so that then we would not have to do this today. We are actually leveraging a third-party solution, Rubrik backup, to in essence back up the ANF volumes from the primary region and make it available in the DR region. We will be able to use a multi-target solution where ANF cross-zone replication and ANF cross-region replication will be available at the same time. The other things we did was for the SBD VMs. The SBD VMs were kind of deployed from scratch in the second region. They were made available for establishing the quorum. And of course, we use the Entra, formerly Azure AD and DNS to facilitate a DR solution. And the solution was also tested by the customer to ensure that it works in the event of DR failover. Absolutely.
Not only backup, but also restore.
Absolutely.
Yes.
Yes. So keep in mind, this whole architecture was deployed was running with 24 terabyte VMs as the customer had, growing pains with the database needing to increase, continuously increasing, and they had to go to the next size. What we did was that we had to migrate off 24 terabyte VMs to 32 terabyte VMs. Now, there are a couple of options we could have done this. We chose the option of doing an HANA system replication migration approach. That's what we did. But another approach, I just want to speak to it, which this customer did not opt for, but is available for customers, is you can do an in-place resize operation. But it's not a simple resize. The reason being the 24 terabyte VMs, when they access the remote disk, they use the SCSI disk controllers. Whereas the 32 terabyte VMs, when they access the remote managed disk, they use the NVMe disk controllers. So if you if a customer is choosing to perform a resize operation and not do an HSR migration, what they would have to do is that they'll have to do a resize plus conversion at the same time. And there's a nice blog written on the Microsoft documentation which talks through this whole process. We actually even ran it for one of the lower environments. At this customer, it works like a charm, and you can actually convert and upsize a VM along with the conversion of the disk controllers. But in this case, for this customer, what we did was the customer provisioned 3 32 terabyte VMs, similar to a 24 terabyte architecture, where there's a primary, a secondary, and an additional secondary in the East US region. And prior to the cutover, they ensured that they set up a HANA system replication from the 24 terabyte VM to the 32 terabyte VM. And as the cutover time came, and during cutover, they ensured that this 32 terabyte VM was in sync with the 24 terabyte VM. They performed a HANA takeover to make this VM the primary, and then establish the HSR application to the other 2 secondaries on the 32 terabyte VMs, and also ensured the load balancer was able to load balance the 32 terabyte VMs using the same IP that it was using in the past. So there was no change to the entire above architecture. It seamlessly was connecting to the 32 terabyte VM architecture. And with that, they were able to decommission the 24 terabyte VMs.
Abbas, that's a beautiful example how high availability, which is primarily for the unplanned downtime, helps here to prevent planned downtime, things like resizing or whatever, maybe OS patch or whatever is needed.
Absolutely.
Which is great.
Yes. I think with that, I think I'm going to turn it over to my colleague Ralf to walk through the...
Just one quick, so I do want to highlight this again, because basically what you're saying is you did the migration from 24 terabytes to 32 terabyte without end user impact or business impact. So the users could continue to work on their Fiori user interfaces. They could batch jobs still continue to run and everything. So for the end user, nothing really happened. It's just you replaced.
Yeah, but not necessarily, because there were other things that SAP recommended them to kind of upsize to their HANA patch level. So there were a few other things that the customer was trying to do. They did have a 4-hour downtime window that they did take. Not necessarily they could have managed this with a very small downtime to cut over from 24 to 32 terabyte VMs, but the other steps and processes that the customer was trying to bring in. So they were able to pull that into this planned cutover window for 4 hours. They did the HANA system patching and other things. But I think our thing was fairly minimal, and they were able to kind of pull it off fairly soon.
Great. Okay, thank you.
Sure, thanks. I think with that, I think I will hand it over to Ralf.
Yeah, no, the real interesting stuff comes storage. Yeah, what we have done here for this customer is that we basically make use of the let's say best 2 worlds for storage. As you know, and if you followed all my last ANF presentations here, we know all the advantages of Azure HANA Files, but we also see here that the log volumes are based on premium managed disks with the right accelerator. ANF does not provide too much advantages besides maybe a little bit lower latency than managed disk here. So the rest of the ANF features and functions does not apply to the active log volume, simply because you have only open files and you cannot snapshot those log volumes, and this some of the very nice features from Azure HANA Files does not apply here for the log volumes. We used normal Linux LVM to create out of those 8 physical SSD V1 drives. We created a stripe set for the HANA log environment, and we use the write accelerator to lower down the latency for the log access and log write for the database. And then we come to the data volumes. The data volumes, we use HANA partitioning to share the load over those 4 NFS volumes, simply because of the amount of writes what you can expect in such a system. Now, imagine the simply a save point such a save point would take usually a pretty long time and needs a very high I/O numbers, and spreading those I/Os over 4 NFS volumes simply is much more effective. And the shared drive, of course, is always separated.
Yeah.
Abbas,
And I guess, Ralf, HANA log is premium V1 disks.
Premium V1 disks, exactly like I said.
Is there any reason why not V2?
Simply, we don't have the write accelerator option on V2. A great question. The write accelerator option, which lowers down the latency pretty much by half. We know that we have roughly 0.6 to 0.8 milliseconds on SSD V2. Here, SSD V1, we usually have a higher latency as SSD V2, but with the write accelerator, we are in that ballpark 0.3, 0.4 milliseconds, which is absolutely great for the HANA log device.
Okay.
Yeah. That was the reason. Yeah, Abbas, can you give me the DR? Because now we talk about a very interesting thing as well. Yeah, Abbas just showed us how the DR is set up. What we also use here is HANA, not HANA, but cross-region replication for the data volumes. And the backup will also take place here on the secondary side. So the backup is usually a big pain for those very, very large systems, because normal backup tools like Rubrics, like Commvault, all the third-party tools, or like the traditional HANA backup, they will back up the data over the client network, where also the database server is connected. Using storage technologies to copy the data over to the secondary region simply gives you the advantage that no interaction or no traffic, let's say, hinders the flow from the database to the database server. Yeah, therefore, those secondary backups using our AZ Snap tool, so creating with AZ Snap a consistency snapshot on the primary side, and that gets copied over then to the secondary side. We will advance this with ANF backup in the next future once I get my additional features, which I requested with the NetApp team. Once we get this, like immutable, indelible storage for the ANF backup blob space, then we will also leverage ANF backup to do this, because then you have the full picture that the HANA server, the client network, and the database is not even impacted at all anymore, taking backups for the data security. And in the near future, once those features are enabled, we can also protect the database for ransomware, for some bad people which are unfortunately out there, to simply because we have an indelible and immutable backups from the log volumes, from the data volumes as well. Yeah, therefore, we have a very, very high security for our customers, because those backup volumes are simply saved for a period of time, and they are immutable, so no one can touch them, no one can encrypt them, and so on.
Cool.
Really cool. Any questions? Abbas, did I miss something? But probably that was the main story. And interesting again, there was also I also wrote a blog about that HANA partitioning for those multiple data volumes, and that works really very, very good. And we see also a lot of performance improvements, especially around delta merges and save points.
Just one thing I would like to add to Ralf is that for some of our large customers, we have used this mixed storage solution where we have used the premium managed disk for HANA log, and we have used ANF for the HANA data volumes, and it's been a great success for us. I mean, I think the HANA log with on premium managed disk is able to take advantage of the M series write accelerator, and the HANA data volumes running on ANF, we have been able to use the AZ snap that Ralf mentioned to kind of take instance. The whole notion of taking HANA snapshot backups is that you can back up within seconds and restore within minutes. I mean, and it's kind of decoupled from the size of the database. You can have a 14, 15 terabyte size database, and you can do this in seconds or minutes, and kind of blows customers away when they hear this. Because imagine on an average, if you're really backing up on a stream-based backup solution, every 1 terabyte of database will take an hour or more. So if you're trying to back up a 15 terabyte database, we're talking 15 hours to backup, and restore times are higher than backup times. So
and with the new AZA snap, it's even quicker. The new AZA snap is even quicker. We come down from a minute to roughly 10 to 15 seconds. So that is really a zero impact to the database at all to create those snapshots here. And last remark before I hand over again to Abbas is that this combination with log devices on managed disk and data on ANF starts also with smaller VMs and also for different database types. Now, when we have the when you see, for example, customers are still having Oracle or DB2 around, then you also will see that this is a big advantage simply because on those VM, we still have that split between the block I/O and network I/O on that network channel, and that makes basically also use of both channels and at the same time. So that is also, in my point of view, a big performance impact, positive performance impact.
Yeah.
Cool. I think with that,
finally,
fantastic. No, fantastic.
Thank you. I think with that, I'll hand it over to Momin.
Right. Yeah, thanks, Abbas. I just want to go over some of the 32 terabyte deployment best practices, some go live readiness. And this slide's pretty, there's a lot of tiles on the slides, probably like a 3-week workshop. I'm just going to condense it here in 7-8 minutes. So don't be overwhelmed, but just some high level things, capacity planning. I know in the portal, we often go in and we just create some E series, D series. These SKUs are specialty SKUs. You won't just be able to create them on the portal like this. There is some capacity planning, whitelisting, quota that needs to be done. So work with our teams. Of course, capacity planning is absolutely critical in the sense that to know when your first VM will be deployed, when will QA be deployed, when will pre-prod, production, DR, have all those dates intact, and then we can line up all the capacity, lock that in for you. So I would say always try to keep that in the forefront. I have seen if we sort of are relaxed on that on projects, things can get a little tight. So definitely be very ahead of capacity planning. Moving on to the next tile, infrastructure setup. I'm a big fan of automation. You'll see that in the cloud is that, let it be SDAF, Terraform, automation tools. You can run these infrastructure scripts to build up the full infrastructure, the basic SAP installs, also deconstruct environments, takes really the human error out. The speed is there for automation. And one thing I like to mention is that when you deploy the infrastructure, use quality checks. Mm-hmm. This quality checks is really a PowerShell script. When you run it, it produces the HTML format. And in that format, it will really give you a listing of parameters, VMs, and we'll let you know that if things are misconfigured, etc. Abbas already talked about the HANA database migration. Of course, this customer uses ASR, but you can use SWPM, backup, restore. All the options are available. Abbas, we can go to the next step here. Sure. I'm sorry, I'll get some water. I'm getting parched. Business requirements are very important. One thing we notice when customers come from on-prem, they're trying to change their RPOs and RTOs from maybe increasing it in Azure, which we have a lot of capabilities to do, but just to having these things laid out. What is the RPO you're trying to achieve? What's the RTO you're trying to achieve? Also knowing certain SLOs and SLAs that what if we promise the business in the sense of if we have some logical corruption and we need to restore the database, what is the timing we've promised the business? Also some SLOs is, batch jobs. How fast should the batch jobs run? What is the acceptable complete time? What's an average dialogue response time in Azure? So these are things that should be predefined as well. Mm-hmm. And I think you've talked about HJ already, Abbas. pacemaker, HANA recommendation. We can go to the next bottom part of the slide here. Backups and restores. This is important factor as well. On-prem, it's definitely on-prem with specific NICs, purpose-built hardware. VMs are a little different where there's throttling at the network layer, disk I/O layer, etc. So really practice your backups and restores. A lot of things sound good on paper, but it's really good before go live to delete a VM, delete a database, build that muscle of the restore capabilities, restore the VMs, get the timings down. So in case things need to be done, that we practice all these things out. And one thing this customer had was snapshot capability, which I think sort of what you mentioned, Abbas, was really neat, that we always think of physical corruption, but what happened if we move some transport and really blow up the environment, right? And that replicates to the HA and DR. How can we bring this and this 32 terabyte we can bring back in like 10 minutes? And that's a huge confidence builder for a team. So really neat technology with the snapshot technology. We've talked about DR. Once again, and I should probably, the go live readiness, do the quality checks, the inventory checks. Whenever we deploy HANA VMs, run HCMT, run through all the testing. Moving on to performance testing. One thing here, it's very hard to mimic a production workload in the sense that I think this is one of like ancient problems in computer science that we try to mimic production, but we really can't. There's load testing tools. There's definitely performance testing. This customer, we did a lot of load testing. And what's neat in Azure, you can build dashboards. So in this dashboard, we were tracking, A&F throughput, CPU, memory, all in just one screen. So my advice is always try to literally break the system, put a lot of load on it. Let's see, is there any bottlenecks in the system? Use NIPing for your app servers, ABAP meter, FIO storage testing, all your third-party interfaces, really test all those out. And that's just overall what I have for best practices.
No, thank you. I think this is really great. And I mean, you mentioned this, but just I want to emphasize this again. You mentioned SDAF, so the SAP Deployment Automation Framework, which basically simplifies the way how the Azure infrastructure is set up. So when it comes to best practices, when it comes to choosing the right storage, the right network configuration, the right setup overall, for me, honestly, SDAF is absolutely amazing. I recently installed an SAP system on Azure, and this is not my daily business. I mean, I used to do this like every other day, but recently I have not done this. And just using SDAF, it was so easy to get the infrastructure in place. And then actually I did want to run the installation myself, but everything on Azure was already pre-configured. And I knew, I mean, you mentioned the quality checks, but I knew with SDAF, it is already installed by best practices. Yes, I mean, I took a look at some of the things, but striping, setting up the disk, all of this was done for me. So this is really an absolutely amazing tool, and it really helps a lot in getting started with all these best practices.
Absolutely. Yeah, George, absolutely amazing. I've had calls Friday evening after lunch. We need an N+1 environment. And quite literally, they ran their automation, and Monday we're walking in with another dev QA production. It was just because previous in my career, that used to take 3 months for me to download the SAP DVDs, order the hardware, rack stack the hardware, and then there's just a lot of human error compared to really there's this automation with the debugging and logging. So very neat.
Cool. Great. Then
a couple of things I just wanted to add to what Momin said on this slide. The priority fencing delay was set up primarily to kind of ensure that whenever the central services, is incurring some sort of a network issue, and the pacemaker has to make a decision to kill one of the servers and make the other one the primary, the priority fencing delay ensures that it does not kill the ASCS server, but rather the ERS server. So it just to make that decision between the two servers, which one to kind of fence. It'll probably fence the secondary, which is the ERS, and not the primary, but using the priority fencing delay. The Azure scheduled event notifications I would let Nolan cover in the follow-up slide as part of the monitoring, and I think it's a great solution that we have implemented. The HANA hooks were implemented primarily when an index server crashes. As the database size grows, it takes longer and longer for the database to come up. So what you want to do is that if an index server were to crash, you don't want to wait for the index server or the database to come up on the same node. You rather want to immediately fail over to the other side, because that's much more faster for the system to recover versus waiting for the index server in a large size database like 10, 15 terabyte database size. So what we did with the HANA hooks implementation is that anytime an index server crashes, you immediately fail over to the other side. You're not waiting on this server to come up, which is the default behavior if you don't implement this. The HANA fast resets was also very helpful. This does not help in the context of a VM reboot, but let's say you're just trying to restart your database on the VM itself while the VM is live. It comes up fairly quickly because it's holding some of the information in persistent memory for you in that context. So it helps. I think if no further questions on this slide, I'm going to hand it over to Nolan for the next slide.
Thank you. Ralph's recipe aside, we've left the best for last. We get to look at numbers and talk about exciting things. So we have two SKUs here, which are essentially the same. One has hyper-threading enabled and one does not. And so you have either 896 or double that, 1792 virtual CPUs with over 30 gigs of, 30 terabytes of available memory. You can attach a maximum of 64 disks. You have local storage, but the exciting stuff comes into the numbers that you see here in terms of the throughput and the number of IOPS you can achieve on these systems, as well as the max network throughput, which is 185 gigabits, which is really amazing. In terms of certification, the 896 is certified for OLTP and OLAP deployments as single nodes. The 1792 supports OLAP, and there's work to enable the 896 to be scale out, as Abbas mentioned earlier, and that certification is ongoing, and we expect that to come sometime in the future. Now you may ask, how are we able to achieve these kind of numbers for throughput and both on the network and on the disks? And that's enabled by Azure Boost, which is dedicated hardware acceleration, which is Microsoft designed system on a chip that offloads the network and storage to a system on a chip that is attached to the host node. It also improves performance for the VMs themselves, because the host node doesn't have to deal with the networking and storage. It's offloaded, so you get better resource utilization of those CPUs that are available to you. And it also enables the NVMe disks. There's also high availability built in, so they're connected to redundant top-of-rack switches. So in the event of a failure there in an external component, your VM is still online and able to perform. So this is very exciting. These systems also use the M-Series write accelerator to enable the low latency on the HANA logs. So there's higher performance there and lower latency, enabling the system to perform well. So I'm from our customer reliability engineering team. So if I didn't talk about monitoring and observability, I think my colleagues and my boss would be disappointed. But these are important topics, not just for SAP, but any workload, and especially for SAP.
And just Krista, so basically these throughput numbers are crazy. I mean, amazing.
They are.
And I just think what Ralf was mentioning, splitting data disk on a ANF network, which is on the right column, and in the middle it's a premium V1 for the log. Basically, I mean it's amazing number of overall, let's say, HANA throughput what you can achieve, so to say, right?
Yeah,
I'm still
definitely.
impressed by just 32 terabytes memory.
Yes.
It's just like
As
I
well.
remember when we had a 1 terabyte database, and this is like Oracle, not a memory database, and that was a really big deal. And now we're talking about 32 terabytes of data put into memory.
What
And it's not
Momin,
the end. It's not the
That's
end.
amazing.
Yeah.
Momin, my
VMs.
first computer was Sinclair Spectrum with 1 kilobyte of.
Yeah, exactly. Quite literally, the
Big
databases
things,
and
Robert.
things used to be like that.
Hey
And,
guys, I need to go to the airport.
Yes, sir.
I think we should let Nolan kind of finish up on the monitoring and the observability.
So just one question I mean, when customer is running this system, what is average utilization from memory and CPU perspective? Did you have that information?
This customer recently went live. I don't have the information at my fingertips now, but Abbas, maybe you have some answers there?
Yeah, we got to look up. I mean, I would expect maybe they will be around 70 to 80% of the memory utilization, around 23, 24 terabytes, I would assume, at this point. And the CPU probably we should be hovering around 30% CPU is what we would expect. But you remember with SAP systems, we all come from that background. It's not the average utilization that really kills the system, it's the max. So when the CPU max goes higher, and that's when, and sometimes I've seen customers move up from 12 terabyte to 16 or 24 terabyte VMs and higher. Primarily not so much because of the memory footprint increasing, it's because of the CPU maxing. And the CPU max are almost making it, or forcing them to move to the next level. I mean, and that's, so in this case, we are seeing 30 to 40% CPU, which is what we want to see. And we don't want to see 80, 90% max, because then what happens is that you're almost looking at an alternative solution going forward. You can't really go up beyond 30 terabytes. You almost scale up at that point would be a consideration for that. I think with that,
thank you.
Yeah, Nolan, you want to kind of just wrap up?
Yeah, I'll quickly go through this so we can get to Ralph's recipe, and he can make it to the airport. So in terms of monitoring, alerting, and response, you know, this feeds into some of the things that Momin was discussing. There are multiple tools, and you know, we recommend using multiple tools and having multiple views into what's going on in your system with tools like Azure Monitor, SAP Solman, Focus Run, and Llama, as well as third-party open source tools to, you know, collect, store, and view metrics and data that you want to see. And all of this feeds into an incident response plan. So having an incident response plan that can utilize this data. If you have a problem and you suspect that it's an application problem, it's useful to collect information from the infrastructure as well in case there's an infrastructure problem that's contributing to it. And vice versa. If you suspect that it's infrastructure, also look at the application and have an incident response plan. When you see a performance problem, collect all this data and get that data as granular as possible to aid in resolving the incident as quickly as possible. In terms of observability, which feeds in here, we've talked about SLOs and SLAs, but you also want to define your SLIs, your service level indicators. What are the things you're actually measuring to ensure that you can achieve the SLOs and SLAs that you're guaranteeing to your business? So it's great to say that you have 99.9% availability, and that's what you're guaranteeing to your business. But if you don't have the actual numbers and the tools looking at the availability of the system, you don't have a way to prove it. And you should do regular reviews of this information, especially after an incident, to make sure that your monitors are catching things and you're able to, you know, see that an SLI is breached before you breach an SLO or an SLA. You also want to make sure you have the appropriate granularity to capture things so that you know, you're not gathering data too infrequently, but maybe when you have an incident, you can increase that granularity to capture additional data. Maybe you're seeing spikes that last 10 seconds, but your data has a granularity of 10 minutes. You're going to miss that. So being able to adjust that granularity during an incident is important. Yeah, that's all I have there. So thank you for letting me join you guys for the first time. I appreciate it.
Perfect.
Any questions?
Thank you so
Thank
much.
you, Nolan.
So
I think
now
with
we will
that-
come. Yeah.
Go ahead.
No, I
Well,
just
go
wanted to
ahead.
say, I think now we can go to the non-technical highlight. Again, this is almost a tradition. Whenever you are here, you share with us a recipe. So
Yeah, real stuff.
what do you have?
I have this time.
The recipe
as I
also
said,
have 2 notes. Yeah, you see.
We also have high availability.
Yeah.
This is actually high availability, and I made this for New Year's for the New Year's evening. It's a really amazing recipe which my manager made for me the first time. And I say, I will steal this recipe because it was so nice. And what you basically do, you have the white fish in this sense. I had a cod fish. And very nice fillets, beautiful. That will also work with other white fish. So I would not go for salmon. I really would stay on the white fish here. And you crunch the potato chips. These are simple, let's say, salted chips. So don't use any paprika or Oriental flavored chips. It's simply the original from Spanish in the sense. Potato chips with only salt. You crunch them, made it like very small flakes, and you do a little bit of salt and pepper on the fish. Then you give this fish. You oversee this fish with a little crust of this potato chips, and then you simply put it in the oven. I put it here in my barbecue, but that works as well. If you have an oven at home, you simply put it in an oven. And you need to see, of course, that the fish really is at the right temperature, but you usually have a feeling for this and bring this on the table. Here, the right picture is how it actually looks like on the table later. Trust me, it is a very simple thing and is unbelievable delicious. So when you made this for me, I almost start crying at his table. It is really... so nice. It is such an amazing recipe. And yeah, thanks to you, I enriches my kitchen here. Guys, and by this, I'm running to the airport. Bye-bye.
Okay, have a nice day.
Thank you so much.
Yeah.
Thanks.
Well, everyone, thank you so much for joining us today. I think this was really an absolutely amazing overview. For me, I mean, we talked about this. I started with the Godzilla machines with the G series at that time. And now we're at 32 terabyte memory. And it's amazing to see that we really have customers that are using this. And it's fantastic to have you already now on the show to talk about this. So thank you so much. And Abbas, you already alluded to it. Maybe we'll see each other again when we are then talking about, I don't know, 64 terabyte virtual machines or something
scale
like
out of the 3 terabyte games. Yeah.
Or scale out. Okay, yeah.
Scale out. I hope scale out.
But thank you, Holger and team, for having me, Ralf, Momin, and Nolan on the call.
Yeah.
We really
No, we
appreciate the
really
opportunity.
appreciate it. The opportunity and the podcasts are always a great way to get information, just very easy to digest. So thank you so much for putting this together.
No problem. Thank you so much.
Thanks,
Okay.
everyone.
Bye-bye.
Bye-bye.
Thank you.
Bye.
See you.
Bye.
Bye.